Hi guys, welcome to Beginner-Techies. In this video, I'm going to discuss about some problem. Okay, so let us go through the problem statement first, so that we can decide what could be the possible approach to solve this problem. Okay, so given a one indexed array of integers number that is already sorted in non-decreasing order, so the array is sorted. Okay, this is first point. Find two numbers such that they add up to a specific target numbers. Let these two numbers are numbers index 1 and number index 2, where 1 less is equal to, so index should be reside between 1 to numbers of length. Return the indices of the two numbers index and index 2. We have to return the index added by 1 as an integer array index 1 index 2 of length 2. Okay, so the tests are generated such that there is exactly one solution. So you may not use the same set element twice. Okay. Your solution must use only constant extra space. So this is what we have to take care while doing the solutioning part. Okay. So what could be the possible approach without using extra space? So this problem is the second problem. I have already discussed about the two-sum problem, but here in this problem we have this condition: your solution must use only constant extra space, and the array is in sorted order. Here I have already solved the another problems. Two-sum problem. Here we have taken extra space hash map to solve this problem, but in this problem we should not use any extra space, so we cannot go with the hash map implementation with the same implementation. So we should think about some other approach. Okay, right. So let me draw example over here. We have this array 2 3 6 11 15. Okay, and the target is what? Target is 17. Okay, so this is the target. So what could be the possible approach? Here the data is in sorted order, array elements is in sorted order. So can we apply binary search? We have another approach, brute force, but as usual we cannot accept this approach. The third one is what? Two pointer approach. We can solve this problem using binary search. We can solve this problem using two-pointer approach. But which one is the best solution in this case? The two-pointer approach will be the best solution because it will give us O of n complexity. And if we are going through this binary search, then we will get n log n. Why this n? Because we have to find out the element from the array. In binary search, generally we have one target. We are going to search one specific element, right? So that specific element we need to find out. How can we do this? Like first we will start from one for loop. Sorry, let me just keep here. This way. Okay, so first we will find out the let me make it sum is equal to target minus what? Target minus a of I. This element will be searched in this array. Okay, with the binary search technique. With the binary search technique. So in that case, we will create L is equal to 0. We will create right pointer. R is equal to A dot length minus 1. Then we will do all the things like we will start while loop, and then we will do this process as we do for binary search. So this way we will like in this case the complexity will be the binary search complexity is log of n, and this one is, and for this loop we will iterate n times. So in this case we will have O of n log n. So we cannot go with this binary search approach because this is not a good, as we have two pointer. So we can go directly with two pointer approach without using any space. We can simply get the result in O of n. So let's see how can we apply two pointer approach. We have this example 2, 4, 5, 9, 11, and we have to find out the target is 14. So we will use two pointer approach in opposite direction. In opposite direction, this technique we will use. So in this case I will denote the left pointer is equal to 0, which will start from here, and the right pointer is equal to A of length minus 1 is equal to what? 3 to 5. Total it is 0 to 4, right? This here right pointer. Okay, now so if we have to check sum is equal to what? A of left is plus A of right is equal to what is this? So 2 plus 11 is equal to 13, which is less than target, right? Sorry, which is less than target. So in this case what we will do, we have to increment what? We have to increment left. So left pointer will be move forward. So in this case left will become left plus 1. So in this case left will be 1, right? And right is still at what? So right is still at 4. Again we will check sum is equal to, in this case, A of left plus A of right. So if you see here, left is 4 and 11 is equal to 15. Now it is greater than what? It is greater than target. Target is 14. So in this case what we will do, we have to reduce right with minus 1. Okay, this one, right? So again we will check. Now the left is what? Left is still 1, but right become 3. Okay, so here again we will check sum is equal to A of left plus A of right is equal to how much? So it is 4 plus 9. Four plus 9 is equal to 13, which is less than target, right? So still now it is less than target. So we have to make left is equal to left plus 1. It means left will become 2 and right is will be same. So in this case again we will do sum is equal to sum plus a, not sum plus a of left plus a of right. So here what is a of left? So at second position we have 5 and at third position we have 9 is 14, which is equal to target. So we can simply return the indexes of both the element. Right, so this way we can solve this problem with the help of sliding window technique. So let us solve this problem. Right, here we have this problem. First we will create two pointers. One is start from 0 and another one is start from is equal to what? Nums dot length minus 1, right? And again we will start from this loop. Sorry, this is not while. We can start from while L left less than right, left less than right. In this case what we have to create this variable sum, and here we will read the values and update into the sum. So this will be left plus nums right. Okay, if sum equal to target, we will simply return here, can create one array, resultant array. Okay, so here left, so this will be right. Okay. Here we can simply return res. So if sum is equal to target, else if sum greater than target, what we will do? If sum greater than target, in this case we will reduce right with 1, else we will increase left with 1. Let me run this. Wrong answer. Right, so here we have to return this is like we have to return index. Indexes should be this one. We have to consider this condition where 1 less is equal to index 1. So in this case we have to add here 1. We have missed that part. So now it is working. We got the result. Let me submit it. Right, 1 ms. Right, so with the help of two pointer approach we are able to solve this problem without using any extra space, right? In the next couple of videos we will do some more problem based on two pointer approach. See you in the next video. Thank you. Bye bye.